Hello everyone, welcome to today's lesson on functions. Right, so this is the second part of our unit, the relations and functions. Okay, so let's begin by a quick review on order pairs. Right, so this is just from my quick little research on Reddit. Right, so I don't even know if that's accurate, but in Legend of Zelda: Tears of the Kingdom, those are the heights of the characters. And now let's write out the order pairs of each character. Oh, excuse me. Hope that wasn't too loud on the mic. Okay, so first of all, we got Link here at the height of 160 centimeters. Right, so when we write order pairs, it's always x comma y. So you can see here, the names are the x values, and the height are the y values. So our first order pair is just Link, comma 160. That's our first order pair. Next is Zelda, clocking in at 178 centimeters. I'm gonna make my text smaller because Ganondorf is a long name. Last is Ganondorf. Alright, clocking in at 300. Right, order pairs. So it's x comma y. Right, and now with order pairs, sometimes a relation can be considered a function. Now a function is a relation where each element in a domain is associated with exactly one element in a range. Right, so each x value is associated with only one y value. And then a one-to-one function is when for every one value of the domain is associated with only one value of the y or the range. Okay, so like that's a little confusing here. Aren't those just the same thing? Aren't all functions just one-to-one functions? Right, but that's not quite because right here, a function is when each element in the domain is associated with one element in the range. But that's the only restriction, which means that multiple domains of multiple x's can equal to the same y. But if there's only one x for one y and that's it, that's what we call a one-to-one function. Okay, so of course, let's check some examples here. So let's take this graph here. What's the domain here? Right, x values. So we got x is -2 here, right, for those two dots. X is -1 for this dot, and then x is 3 for this dot. So -2, -1, and 3. Alright, remember we do not repeat the same if we have the same number. How about the range? We got y equals to 2 up here, y equals to 1 here, and y equals -2 here. Again, in numerical order. Okay, so is that a function? Okay, so we can see here that in this case, x equal this is 2 and -2 too. And this right here is -2 comma 1. Okay, we notice something here, right? Even though this is a relation, we see this x value -2 associates to the y value of 2, and -2 also associates the value of 1. Alright, so we have one x value, which is -2, that relates to two different things in the y value, 2 and 1. So this right here is not a function. Alright, this is not a function. Okay, how about this one? What's the domain here? Alright, so we got Miss A. Alright, the x value, so Miss A, Miss B, and Mr. C. I got Mr. C twice, but we just write it once. Even though I think I'm important enough to be written twice, but whatever. And then the y value, the range, cars, soccer, sleeping, and breakdancing. Realistically, on a test, I'm not going to give you long words to write, because that's a waste of time. I just need to make sure that you understand what the x and y values are of the order pairs. Breakdancing is a long word. Okay, now is it a function? Let's see. So again, each x value can only associate to one y value. So Miss A associates with cars, that's good. Miss B associates with soccer, that's fine. Mr. C associates with sleeping, that's fine. But again, Mr. C associates also to breakdancing. That's a second item in the y, right? Which means that it's not a function. Right, so the same x value can only be associated with one y value. Okay, how about this one here? We got number of wheels, that's mapping notation. So the x values are bicycle, car, motorcycle, tricycle, and unicycle. Okay, and the y values, just 1, 2, 3, 4. Okay, is that a function? Finally, we got a function. Okay, notice here how the bicycle associates with 2. That's one thing. Car associates with just a 4. Motorbike associates with a 2. Right, so notice here that both of those x values associate to the same y value. Right, so in this range here, 2 things associate to the range. But as long as the x value only associates to one thing, that's fine. Right? If bicycle associates to the 2 and the 4, then that's not a function. Right? So motorbike, 2, that's fine. Tricycle, 2 to 3, one thing. Unicycle to number 1, that's one thing. So that's finally a function. But yes, in this case, it's not a 1-to-1. Okay? Because there are 2 things associated with this 2 here. If, let's say, the motorcycle is not in this picture, right? If this is the our relation, then this right here is a 1-to-1 function. Okay, how about the other way around? So x is just reverse of that. So 1, 2, 3, 4. Right, we've just like swapped places. That's x. That's the y. Of course, I'm too lazy to copy it all down. Let me just hit up copy and paste. Okay, is that a function? Right, we notice here. Right, so 1 associates with one thing. 2 though, the number 2. Right, watch how the number 2 associates with 2 things. Right, so that's a no-no. That's not a function. 3 associates with 1, 4 associates with 1. Right, but because the number 2 here associated with multiple things, right, that is no longer a function. Alright? But here's an easier way to tell if something is a function or not. We do what we call vertical and horizontal line tests. Right, so what we do here is we want to imagine drawing a straight line along a function and a horizontal line along the function. We're essentially just scanning this function. If this line crosses 2 points, then that is no longer a function. So let's look at this example here. Vertical line. So we can start drawing lines, right? Think of it as a ruler scanning across the entire thing. So can I even do this? Surely there's a line function I can do. Okay. Oh, it's an arrow. Oh, that's neat. Oh, I can choose colors. Let's do pink. Don't think I have a pink. Okay, so here is our little line here, right? Does it move? Or what do you mean does not move? What? Oh, probably should have tested this before I recorded this. Okay, anyways, so think of having a line, right? Go through our graph here, right? Oh, there we go. Ha. I think of a line, a vertical line going through our graph here, and we are essentially scanning it. The moment we get to a point where the line touches 2 separate points on the same graph, then it is no longer a function. Right? So, as you can see here, there's no point in the graph where it touches the line twice. Okay? How about, so which means that this right here is a function. How about if it's a 1-to-1 function? We can tell if it's a 1-to-1 function by doing a horizontal line scan. So we scan this line horizontally to see if there are any points, any part of the graph where the line touches it twice. There's none. So it's also a one-to-one function. Right? The reason why this works is because if we hit, right, if this line hits 2 points on the vertical line, that means that x has multiple y values. Right? Because again, we do not want x to have multiple y values. Okay, now domain range. What's the domain range here? Right, you can see here, it goes on infinitely to both all the x's and all the y values. So it's all real numbers. Again, we use this symbol to denote that. All real numbers. Okay, done. Next one. Okay. So this one here, right away, we notice here that with our vertical line scan, it hits 2 points on the graph, right? We got this point here and then this point here. And I guess this whole part here, right? No matter where you go on this graph, we always hit 2 points, right? Which means that this is not a function. If it's not a function, it's also not a one-to-one function because it's not a function. Right, so even though it passes the horizontal line test, right, even though that's fine, right, but because it's not a function to begin with, it cannot be a one-to-one function. Right, because you can see here that let's say x is 2, right? If x is 2, then this is, I don't know, 2.5-ish, 2.5. And this right here is, oh, that's not really well drawn. It should be negative 2.5, but it's probably around negative 2.1. Right, notice how that the x, right, the same x has different y values. Right, that's why it's not a function. And that's how the vertical line test works. All right, review time. Domain. What's the domain? What's the smallest value x can be? Right here. Biggest value x can be? That's infinite, right? Those two lines go on to infinity to the right. So the domain is as long as the x is big or equal to negative 2. That's part of the domain. How about the range? Right, with the small and biggest y value, right? Because we know those two go infinitely, right, we can assume that the y values are just infinite. Or all real numbers. Right, because those lines extend to infinity. Okay, next. Is this a function? Let's see. Drop the vertical line. Right? And as you can see, as we scan this vertical line around across the graph, at no point does it touch 2 points. So that's a function. Horizontal line, right? You can see right away there that it touches multiple points horizontally, right? So it's not a one-to-one function, but it is a function though. Okay, so what's the domain range? You can see here, smallest x value, right, and the biggest x value, this line goes to infinity. So x is all real numbers. How about the range? Smallest y value is right here at -1. Biggest y value goes on to infinity. So as long as y is bigger or equal to -1, that's part of the range. Okay, here's a trickier one. Like, what is this, right? I will say this is more in the extending category here. It's not a function. Let's see. So far, so good. Until we get to this point right here. Right? So at this point, right, we notice something here. Right? Even though it touches the graph at 2 points, because both of those points are hollow, it actually doesn't really touch the points. Right? At this point, where both two dots are at x negative or x equals to +1, because both of those dots are hollowed out, we actually do not cross it at all. So that's fine. And also here, at x equals to -1, notice how this upper dot is plotted in, but the lower dot is empty. Right, so we actually do not come across 2 points. It's only 1 point here that we're crossing, so that's still fine. Right, so as cursed as this graph looks, it's actually a function. Now, is that a one-to-one? Probably not, right? If we just draw a line, you can see here already, this line literally touches every single value in those line, right? Okay, here's a hard one. What's the domain here? Okay, let's see. Right, so from here, from -3, right, all the way from here to here, right, we have -3, bigger, oh, sorry, -3, bigger or equal to that, but smaller than -1. Right, it's no longer equal to because it's a hollow dot. But, right, but we notice here that -1 is actually included. -1 is actually included up here. Right, so it actually also includes -1. But what doesn't include is +1, right? Because the point where we have +1, right, because we have two hollow dots here, we do not include +1. So our domain is from -3 to +1, right? So from here, all the way till here. Right? So this part is part of the domain. But we also notice here that it actually goes up to 2. So there's actually another section here for the domain. Right, like that, right? Because we also have a section here between the 1 and the 2 here that the x value also includes. Right, but again, in either cases, we do not include the 1. And the y. Now this is the cursed part. Y actually is commas, right? Because y value is only here at -2, here at 1, and here at 3. That's it, right? There's no y in between any of those places. So in cases like this, right, y is just -2, and then 1, and then 3. Okay, so this one, again, this one's really hard. I see this probably extending category, right? This is a very hard question. This requires you to have a pretty good understanding of domain and range. Okay? And now the last part is discrete and continuous. Right, so you can see here, why do we sometimes connect the dots and sometimes don't? And that all depends on context. Right? Something discrete, in this case, have separated values. Right? In discrete, we do not connect the lines, we just have dots. Right? No lines. And the reason why is depending on context. Right? In this case, we cannot have half a DVD. Right? Because if we do a line, right, then that means every single number inside the line counts. Right? So we have 1 here, right? And then 2 here, and then 3 here. Or 1, 2, 3, 4, 5, right? We have 3 DVDs, 5 DVDs, and so on. But what about here? Right? If we have a line, then that means this point here, for example, also is inside this graph. This is 1.5. And we cannot have 1.5 DVDs. So, depending on the context, if it's not something that we can just split up infinitely, then we have to make sure to not connect the line. But with continuous, right, we draw the line because it includes all the numbers inside the line. Right, so it could be this point here where we have, say, like 2, 2. Of course, that's probably not it. Right, we can have any point here, right? We can maybe have 3.2 hours, and then we can have, I don't know, 200.978 meters, right? So whenever this number, whenever we include every single number between the points, then we draw the line. Sometimes, like with DVDs, we cannot just have half a DVD or 0.75 half DVD, so we do not draw the lines. But that's it for today, though. Right? A function, you can check it by using a vertical line, and for one-to-one functions, you can check with horizontal lines. Okay, but at the end of the day, just make sure that only one thing can be mapped to a range. Right? So here, -2 is both 2 and 1, so that's not a function. But here, even though bicycle is 2 and motorcycle is also 2, right, but because the domain only has one y value, that's fine. But with that being said, that's it. So, good luck practicing.